you need to build the facilities where the feedstock is to have the biggest impact on growing the bioeconomy. It's going to have the most cost savings. It just makes the most sense. And folks that, especially what I saw in Indiana, you have a skilled workforce there because of the thriving corn industry. So that's number one. But in terms of supply chain, why wouldn't you just make it right in the U.S.?
Welcome to Agbioscience, the #1 podcast in the world for innovation in food, animal health, plant science, ag tech, and agriculture. Welcome to Agbioscience. I'm Kayla Chittister, producer of the podcast and this week's host of the show. From agbioscience innovation to defense, pharma, food and nutrition, and beyond, the bioeconomy is broad. And the intersection of innovation, research, and policy creates a lot of questions when it comes to how we grow and scale to make us competitive right here in the United States. This week, we're joined by Sarah Glaven. She's a visiting fellow at Princeton University's Andlinger Center. She's also former White House, Pentagon, and Naval Research Laboratory biotechnologist. We learn a lot from Sarah about the bioeconomy, what it means to her, and how she sees it growing in the future. Please enjoy this discussion with Sarah Glaven on the podcast. Sarah, thanks so much for joining us on Agbioscience.
Thank you for having me. I'm excited about this conversation.
Yeah, me too. We have a lot we're going to dive into, but we would be doing this podcast no justice at all if we did not start from the absolute top, which is your story. And so I want you to share with us from the very beginning the Sarah Glaven story, and please leave no stops along the way out. How you got to Princeton University and the story of you becoming who you are in the bioinnovation space.
Yeah, sure. That's a great story. I like it. So hopefully others will be entertained. So I grew up in a rural part of Western Massachusetts. It's just an absolutely beautiful area, and spent a lot of time out in the woods. And growing up, it was really fun until I got to be, like a teenager. All I wanted to do was leave, because, you want to see what else is out there in the world. So I was on a college tour. I can't remember what university. It was somewhere in Boston, because that was the big city. If you grow up in Massachusetts, that's where you're gonna head. And I was hearing about this major in environmental science where you got to go to the Amazonian rainforest as part of your research. And I just thought, wow, that sounds like so interesting and so special. And I could go study fruit bats in the Amazon. And it was like the moment that catalyzed for me that what I wanted to do for the rest of my life was have adventures that were related to science. So I didn't actually end up going to school in Boston. I ended up at the University of Massachusetts in Amherst, which was only about 45 minutes away from where I grew up. But that was the first step in what became now a pretty long career in environmental science, in energy and environmental science, in biotechnology, using biology really as a way to both come up with technological solutions that impact society, and just solve some of the biggest issues that we face today. So the first technology I worked on was something called phytoremediation. I worked on this during my PhD, where we use plants to actually essentially filter drinking water in a way that removes toxic contaminants that might get in there from industrial processes. And so where I studied this topic and did field research at the Savannah River site, which is in South Carolina. So I spent my graduate school days at the University of South Carolina, which was very interesting and fun, and I really loved being in a different part of the country. And I also liked that the Savannah River site was it was a site that's owned by, or it still is a site that's owned by the Department of Energy. And it was like a playground for doing innovative research in biotechnology. So we were allowed to do field sites and field tests on things that we wouldn't normally be allowed to. And I think that this is actually really important because a lot of times people go to graduate school and they spend a lot of time in the lab, but they're never trying to implement something in the real world. And that was something that I got to do in graduate school. So I always knew that no matter what I did next, I wanted to be really oriented towards technology. Funny how research careers go, though, is sometimes you pivot based on, especially when you're in graduate school, based on where funding lies or whose lab you can go spend time in or do research in. So I actually ended up back at the University of Massachusetts after South Carolina, and I thought I was going to still work on cleaning up the environment, still work on making drinking water safe. But when I got there, the professor I was working with decided that my project was going to be in an area called microbial fuel cells. And this is because that's what he needed somebody to work on. But it turned out to be a huge opportunity that I've spent essentially the rest of my career working on, which is how can microorganisms make useful products for, I guess, society's needs, right? So in this initial case, it was, can we get microorganisms to make electricity? Like we figured out a way to harness energy from microorganisms that could power a light bulb or recharge a battery, those sorts of things. And it was super exciting and interesting. But that slowly transitioned into what else can we make for society? And it also led to my time at the U.S. Naval Research Laboratory. So continuing on that theme at the Naval Research Laboratory was really interesting because we started asking questions like, well, if we have the pharmaceutical industry making things for human health and for, essentially medical purposes, what about the rest of the space? Like the people use all kinds of products, they use all kinds of things, and a lot of those are relevant to the defense space. So at NRL, that's Naval Research Laboratory, I got to think about how can we get microorganisms not necessarily to make electricity, but to make materials and to make other chemicals that we really need from a supply chain perspective, that we might import from other countries, that it's really important that we have in the United States. How can we get microorganisms to make things that we don't even yet know we need, like entirely new types of materials? And so I did research in that area for a while, and eventually it led to me leading up a big program for the Department of Defense where I oversaw many teams working in this topic area. How can we build up and demonstrate those technologies at a prototype level? And then while I was doing that work, I got asked to go over to the White House, to the Office of Science and Technology Policy, and lead a similar initiative, not only for the Department of Defense, but for the entire federal government. And so that's really when I got the biggest, broadest view. So my time at DoD ended recently in the spring of this year. And I decided that something that I needed to do in order to be better at my job, or better at my job if I go back to the federal government, was understand what the perspective of the private sector is from technology development, from their interaction with the government, what the real needs were in the United States to expand this biotechnology space, to expand the bioeconomy. I needed to understand that from that perspective as well. So I'm spending time at Princeton for 1 year as a fellow with the Andlinger Center for Energy and the Environment. And it's allowing me to think about what the future of industry looks like as we move to a time in history where we're going to have abundant electricity that we need to generate for all sorts of industries and technologies. How is that going to impact biomanufacturing? What do we need to do in the United States to responsibly expand the biomanufacturing sector in a way that's going to match our needs in the future for sustainability, energy, and the environment? And it's just been incredible so far. It's only been a couple months, but I've really just enjoyed it.
The bioeconomy, it touches so many areas, including Agbioscience, which is why we're here today, right? But healthcare, pharma, industrial, strategic and defense, and more. So to create a simplistic explanation of this question, how do you define the bioeconomy, and what do you believe is its importance to our country's future?
Well, that's a great question. And it sounds... I'm going to give a simple answer, but understanding that it's more complicated than this. So because I worked for the federal government for a long time, and I worked from the perspective most recently of a policymaker, and how definitions are so important for setting policy because they line up essentially what gets included in that policy. I'm going to use, and I tend to use the definition that the National Institutes of Standards and Technologies developed with other stakeholders in the federal government in response to an executive order in 2022. And so that definition of the bioeconomy is economic activity derived from the life sciences, particularly in the areas of biotechnology and biomanufacturing, including both the industries, products, services, and workforce that are part of that economic activity. This definition, I would say, is very U.S. centric, and perhaps could include some slightly different language from the perspective of industry. But I will tell you for sure that it could be vastly different from country to country. So I think this is a good definition of what it means to the U.S.
And what is its importance to our economic competitiveness?
So that's also a really great question. So I'm not an economist. I'm a biologist. I think everyone got that from my background. But the bioeconomy essentially touches every sector of our economy, whether you're talking about the food industry, the agricultural industry, the defense industry, or the healthcare industry. So as we think about the way that we get the products and materials that we use in our everyday lives now, a lot of those products and materials could actually be made using processes that involve biotechnology and biomanufacturing. So number one is that the bioeconomy is growing. We're going to make more and more products from biology. So I'll give an example. Right now, you could point to most materials in your home, whether it be the veneer on a table or the packaging and the food in your refrigerator. And a lot of those products contain materials that are derived from fossil-based feedstocks, so oil, natural gas, that make chemicals that then eventually get converted into that material. Biology can make those same chemicals starting with sugar or starting with other types of input that we already have above ground, like recycling carbon dioxide or recycling carbon from waste streams. And in the future, that is where a lot more of our products are going to come from. And that all gets captured in this big picture of the bioeconomy.
What would you say, Sarah, are some of the biggest headwinds in your experience that we're facing when it comes to the growth, but probably more challenging is the scaling of the bioeconomy?
Mm-hmm. Yeah. So those are great questions. And I think I would have to, there are a lot of different headwinds as there are with many different emerging technologies and emerging industries. So I'll touch on a couple that I think are some of the biggest. And you implied first, actually scaling. So scaling is a huge factor. It requires investment in infrastructure and physical steel in the ground in order to be able to make enough of a product that it's commercially viable. So, and those investments are hard to come by. So, imagine if you have driven down the road and you see, I spend a lot of time in New Jersey. So if I'm driving down Interstate 95 and I see a chemical refinery, right? Those are massive complexes with huge, pipes and towers and all kinds of stuff. I mean, a full-scale biomanufacturing facility, a commercial scale facility, isn't going to look too much different than that. There's going to be a lot of different things going on inside, but it's a big footprint. It requires a lot of infrastructure, and it's not cheap. But it's that scale that then brings down the cost of the products, which is a barrier right now. Compared to more conventional products. The second thing is the workforce that's required to man these facilities, right? So like there's people that are scientists that are highly educated with all the, understanding of how you get from sugar to a piece of food packaging material using living systems. There's people that have thought about that. They understand all the intricate biology, but those are not always the most important people, because in a big facility that's needed to actually scale up production, you're going to need skilled workforce that understands fermentation, that understands chemical engineering, that understands welding, that understands, everything that would be part of plant operations, but it's going to look different than anything else that we have right now. And then the final piece is the regulatory piece of the puzzle, because, like I said, there's many pieces, but I would say these are my top three. The biotechnology regulations that we have in this country right now don't fully address the needs of the modern biotechnology industry. They're either too focused on something that's related to healthcare or specifically to agriculture, but not the full value chain of the product when it goes from sugar that's part of corn crop all the way to now that material is part of the food packaging, right? And there's regulatory steps all along the way that just need to be updated and considered, because so that they don't actually hold back innovation.
Yeah, there's a lot of players at the table that it's going to take to achieve that kind of growth, and we'll get to that right after the break. Agbioscience is supported by Indiana Farm Bureau.
From berries to dairies, from crop advisors to data analyzers, Indiana Farm Bureau is at the forefront of the top issues impacting Indiana agriculture. No matter your role in the ag industry, Indiana Farm Bureau membership means you'll always have a champion and an advisor. And because so much of your time is focused on your own enterprise, it's also good to know Indiana Farm Bureau is always working to fight for the future of agriculture. We come together to advocate for rural viability, the protection of property rights, competitive tax policies, and against burdensome regulations. Whether our members need a door opened, an impact in public policy, or an ally to strengthen their communities, Indiana Farm Bureau is there. We are the unified voice for all agriculture. To learn more about the benefits of Indiana Farm Bureau membership, go to infb.org.
Welcome back to Agbioscience. We're talking with Sarah Glaven. Sarah, you've obviously held some critical roles, and we got into that meat a little bit earlier. How did those experiences shape your perspective on this critical alignment that's needed of policy, innovation, and research?
Yeah, that's a great question. So, having spent many years just in the lab, leading research projects, I think you don't have quite the perspective of how your day-to-day life is impacted by policymakers. And you also don't quite always have the vision of how your work in a lab setting is going to translate into that technology much further down the line, that innovation piece. And so I'll tackle one at a time, but then I'll say how they all kind of go together, right? And then I think it's really relevant to the conversations that are being had right now within the government, because the innovation timeline can take many, many years, especially in biotechnology. It's not a quick return, but something that the United States has always been very, very good at is the front end of that innovation pipeline. So if you're thinking about, starting from an idea to a full-scale biomanufacturing facility where now you're making this crazy new material that's going to solve some kind of major societal problem, and it's affordable and it's the best solution and everyone wants to buy it. There's a lot that goes on in between those two places. And so you have academic researchers, or like myself at a government laboratory, toiling away in the lab. We're spending our entire career coming up with ideas and then doing that first step that makes the idea a reality, and then sometimes patenting those ideas. But someone has to pick up the thread along the way. And that's where things get tricky for the bioeconomy, for many different pieces of the bioeconomy, because there's risk involved in that. And we haven't, as a society, always been good at taking that risk, because we want there to be a quick return, and there isn't always that quick return. But that's that place where you can enter the valley of death. So if you take the technology from the lab, you start to demonstrate it at a bigger scale, and it fails, which a lot of them do, then it's kind of, it gives like a negative, like a bad taste in the mouth. But that's exactly what we need to make innovation happen faster. We need, at that valley of death phase, to move faster, fail faster, and fix it. Like, we just have to move on. And then finally, once you get through that phase, the innovation phase, I already talked about scaling up. That's a big problem there. For policymakers, the biggest issue with policymakers in the bioeconomy space is there are so many different aspects that have to be taken into consideration along that innovation pipeline that it's hard to know exactly what to spend the most time on. If you ask company A, they'll say one thing. If you ask company B, they'll say something else. But I think for policymakers, a big challenge is that it takes a lot of subject matter expertise to cover that entire bioeconomy space. So you can't, it's impossible to have technical or policy making expertise across the whole spectrum. So it really takes a village, if you will, to actually create both an innovation and a policy ecosystem that's going to foster the expansion of the bioeconomy in a rapid way. So I would say removing barriers, coming to consensus quickly, and moving faster, especially through that middle phase, the test prototype development phase, is what's going to help everybody get to where we want to go faster.
If you had to give us a grade today, how are we doing today?
I think better than average. So what would that be? Like a B minus?
I like B minus.
Yeah, I mean, I think B minus. The reason I say that is reflecting back on the last decade or so. It feels a bit like two steps forward, one step back. So there's kind of fits and starts. I think that that's a function of just the way our economy works in general. And there's probably advantages to that, but I think when we're trying to push, we need to stay focused on certain initiatives for a longer period of time than 2 years in order to see them achieve success.
Thanks for grading that for me. From the feedstocks made available by Indiana farmers to innovators working in our state's ag biosciences and life sciences sectors, the bioeconomy is alive and well here in Indiana where we're recording this podcast. Yes. How do you see reshoring biomanufacturing supply chains sort of reducing disruption and creating some of this U.S. competitiveness we've been talking about?
Yeah. So I was in Indiana last week or 2 weeks ago, sorry. And it's true. The Midwest is thriving. It's the heartbeat of the bioeconomy in the United States. I just couldn't believe, we have corn in Western Massachusetts, but it's not like Indiana. And I never knew that there were so many products that were made from corn at a single facility. I mean, you just pump it out. Like Indiana is the bioeconomy, and there's strong support from the Indiana Congress people, particularly Senator Young. I mean, he chairs the National Security Commission on Emerging Biotechnology, which is playing an absolutely critical role in making sure that policymakers consider how important the bioeconomy is to U.S. competitiveness and national security. I mean, it's absolutely critical in terms of growing the manufacturing industrial base in the United States and its impact on sustainability, supply chain sustainability, supply chain security. It's just absolutely necessary. I mean, you need to build the facilities where the feedstock is to have the biggest impact on growing the bioeconomy. It's going to have the most cost savings. It just makes the most sense. And folks that, especially what I saw in Indiana, you have a skilled workforce there because of the thriving corn industry. So that's number one. But in terms of supply chain, why wouldn't you just make it right in the U.S.? I'll give an example. So for some of the products that I've mentioned that are not related to healthcare. So if you're in Indiana, probably very familiar with, okay, we can use corn and we can convert it into ethanol. And that's a thriving corn ethanol industry, which is used for fuels. But there are all kinds of other fuels that you could convert corn to that are not ethanol, and they require similar type of infrastructure, but we don't have that infrastructure in the United States right now. And so even for the demonstration projects that I've been responsible for leading for the Department of Defense, we sometimes had to ship some of the technology overseas to Europe. Then they would brew up a batch of the chemical we were interested in, and then it had to be shipped back to the United States. I mean, that doesn't even make any sense. And we're just talking about for test and demonstration. So if we want to keep technology in the United States and fully benefit our economy, then we absolutely have to make sure that we're expanding the manufacturing infrastructure right here where we can.
Yeah. You mentioned a skilled workforce, and as this segment of the economy grows, that skilled workforce is going to have to grow too. Are there some best practices you've seen across the United States in terms of partnerships and programs to whether it's upskilling or developing talent for biotechnology and manufacturing that just have really impressed you, that are worthy of story?
Yes, there are a couple different universities, which I'm not going to remember. I'm going to say something incorrectly about them, but in North Carolina and in parts of Northern California, the biomanufacturing industry has been able to set up education programs right on college campuses where the students are getting hands-on experience with how to operate some of the manufacturing machinery and processes that they're going to need to operate once they enter the workforce. And there's a direct pipeline into biotech companies that are located nearby. So those students feel like when they're done with school, there's a job waiting for them, right? So I think that that's an important aspect of this. And I think that the emphasis doesn't always have to be on the bio part of the jobs. It's like, if you're a young kid, if you're 20 years old, you want to know that you have a job when you graduate college.
Yeah.
It doesn't have to always be explained. I think the skills need to be emphasized more than the cool science, because I think sometimes scientists like myself do ourselves a disservice by not emphasizing that there's a skill required that's transferable to lots of other different types of jobs.
Well, it's obvious you have a love for this science, this industry, and its potential in the future. And so I have to know, what has you the most excited about its opportunity, its potential, the bioeconomy future, Sarah?
Well, that's easy. So the thing that really excites me the most is we're at this time in the history of our country where we're seeing, the bioeconomy is growing. There is absolutely no doubt about that. You don't even have to take my word for it. There's lots of reports written on this, but there's also other really cool industries that are growing at the same time. And I would say the office I worked in at the White House was called the Industrial Innovation Office. And I was just thinking about semiconductors and clean energy and just all kinds of things that are going to define what the future of our country looks like, both economically, technologically, and just like how we live our lives every day. And biotech is going to be a huge part of that. And I think what's exciting to me is that it's going to grow alongside these other industries. And it's almost like a new industrial age is kind of how I think about it. And specifically, and more of a nerdy science thing that's built in there is the field of synthetic biology, where we understand biology enough to manipulate biology in a way where we can make things that we've never even dreamed of before. Like, we can get microbes to make concrete. We can get microbes to self-assemble into large structures, building materials that we can then use to do types of construction we've never thought about before. And we can use them to address different types of issues with our food supply. So that's what I'm really excited about. I want to see what microbes can do and what we can do with them as we come along this new industrial age.
Where can people find you, Sarah?
Well, I live in Washington, D.C. I go up to Princeton during the week. Connect with me on LinkedIn if you'd like to chat more. And otherwise, hopefully I'll see you in Indiana at some wonderful corn facility sometime in the future.
We welcome you back anytime. Thank you so much for coming on Agbioscience.
Thank you very much.
And thank you for joining us on Agbioscience. On behalf of the entire AgriNovus team, we'll see you back here next week on the podcast.
Agbioscience is a podcast by AgriNovus Indiana, brought to you by Indiana Farm Bureau. Produced by Kayla Chittister and Fabian Rodriguez. Photography and design by Kaylee Verstay. Video by Darren Cooper and 1898 Creative. If you like today's episode, subscribe, rate, listen, and review. Get all episodes of Agbioscience online at agrinovusindiana.com.